The non-hydropower. The Three Gorges Dam, which is the world's largest hydroelectric power plant, built on the Yangtze River in the Hubei province of central China. The Three Gorges Dam power project is the biggest hydroelectric dam in the world. The 2.3-kilometer long concrete gravity dam is designed to control massive floods in the flood-prone upper sections of Yangtze River by diverting them downstream. Equipped with 34 turbo generators, the power plant has an installed capacity of 22.5 gigawatts. It has a 483-meter-long spillway, a left powerhouse, and a right powerhouse. Operational since 2003, the $31 billion hydroelectric power plant is a major source of electricity in East China, Central China, South China's Guangdong province, and other regions. Owned by China Three Gorges Corporation, CTGC, it created the world record of annual power production from a single hydropower station in 2020, generating 111.8 billion kilowatt-hours. The power plant helped avoid the use of 31.7 million tons of coal and eliminate 86.7 mt of carbon dioxide, 19,600 t of nitrogen oxide, and 20,600 t of sulfur dioxide. Although the dam helps produce cleaner power and reduce reliance on coal, which China burns in large quantities for water generations, the power project faced questions over its ability to withstand heavy floods. Three Gorges received its largest flood peak since it became operational in August 2020, after torrential rains raised inflows to the dam. The project was claimed to have passed all flood control and power generation tests in November 2020, allaying doubts over its efficacy. The Binga Hydropower Plant. Following commissioning in 1960, the Binga Reservoir filled rapidly with sediment due to an underestimation of the sediment load and the absence of any sediment management strategy. When Binga Hydropower Plant was acquired by SN Aboitiz (SNAP) in 2008, it was not operational. Sediment management is crucial to keeping the plant operational as a run-off river project. Binga Hydropower Plant, owned and operated by SN Aboitiz (SNAP) since 2018, is located in the upper reaches of the Agno River, on the island of Luzon in the northern Philippines. The plant was commissioned in 1960 with the purpose of generating electricity and providing flood control services. 3 dams in a cascade complex on the Agno River supply water to the 105 megawatts Ambuklaw, the 140 megawatts Binga, and the 345 megawatts San Roque hydropower plants. Binga Dam, located 19 km downstream from Ambuklaw, is a rock-filled dam with an inclined clay core. At a height of 107.4 meters, the dam crest elevation is 586 meters above sea level, and the dam originally impounded a volume of 95 cubic millimeter. The maximum and minimum operating levels of the reservoir are 575 and 566 meters above sea level, respectively. The spillway is located at the left abutment, while the intake is on the right side, leading to the underground powerhouse through an 800-meter head-raised tunnel. The designed spillway discharge of a return period of 10,000 years is 10,521 cubic meters per second. Following its refurbishment in 2013, the 140 megawatts Binga plant now hosts 4 Francis vertical shaft turbines of 35 megawatts each. The net head is 156 meters and the design discharge is 25 cubic meters per second. The average annual generation is 238.43 gigawatts hour. The hydrology and sediment in Banga. The catchment tributary of the Bingan Dam comprises 936 km squared, of which 72% is regulated by the Ambuclao Dam upstream. Although the Ambuclao Reservoir traps most of the sediment, the Bingan tributaries, the Liboy, Adunot, and Bisal rivers, carry very high sediment loads. This is deposited in the upper section of the Bingan Delta. The Philippines is one of the countries most exposed to tropical storms. Approximately 20 cyclones and typhoons hit the country each year. They are concentrated in the months of June to September, but can occur throughout the year. Due to its geographical location, the Philippines also suffers from high-magnitude earthquakes. Since the middle of 20th century, there have been 8 earthquakes above 7 points in magnitude. In 1990, the island of Luzon experienced a 7.8 magnitude earthquake. As shown in Figure 2, the water inflow to the Bingan Reservoir has increased over the years, with the peak flow reaching up to 2,000 cubic meter per second in 2017. The mini hydropower plant in Sevilla. The Sevilla Hydropower Plant is a runoff river mini hydropower plant on the Loboc River on Bohol Island, in the central part of the Philippine archipelago. The plant is located in a well-known tourist area near the Chocolate Hills and a natural reserve of tarsiers, about 5 km upstream from the town of Loboc, where river view cruises take place. Construction of the plant, including electromechanical equipment, was financed from the World Bank loan budget provided for renewable energy development in the Philippines. The local administrator of the budget was the Development Bank of the Philippines. The developer loan purchaser and now the operator of the plant is Bohol Electric Cooperative I. The original design was improved by the consortium of CREA Hydro Energy members during a tendering procedure that allowed better hydraulic parameters to be obtained. The final winning design reached 1,729 kilowatts of the maximal output, and the Czech consortium led by Strojerny Brno was awarded the contract of the detailed design, manufacturing, supply and installation of electromechanical equipment. The equipment comprises 2 vertical Kaplan turbines, 2 vertical synchronous generators, hydraulic governors, electronic control system, electrical output including transformers, intake gates, stop plugs, overhead bridge crane, and auxiliary equipment.